Welcome to the Adapter and Connector webinar. My name is Becca and I am on the Origin One team, and we're very excited to have Dan Straka, General Manager at Interpro Additive Manufacturing Group, and Tim Downing, Application Engineering Manager at Origin, here with us today. We're going to learn a lot about how to print parts that have thin walls, pinholes, and high accuracy requirements, and we're going to make sure that they print beautifully and reliably on the Origin One. We're also going to go through why you should print these parts and also how the Origin One fits into the Service Bureau ecosystem and hear a bit about Dan's experience. We're also going to get, at the end, a sneak peek of the Interpro Origin Labs. So make sure to stick around for that right before our Q&A. I'd like to I'd like to let our speakers introduce themselves to you before we get started. First off, we have our guest speaker, Dan Straka, General Manager at Interpro, as I said, which has been offering 3D printing manufacturing services for almost 30 years. We're so glad you're able to join us, Dan. Can you tell us a bit more about your background?
Oh, yes, thanks for having me. It's exciting to be able to talk about our success with Origin. For a while, Interpro kept it a pretty closely guarded secret. But as the industry has evolved and as we have grown, it's really one of those things that we need a lot of people kind of preaching the gospel to get the word out there, to educate customers, to know that these are, viable solutions for advanced prototypes and production. Yes, my name is Dan Straka. I'm the general manager of Interpro, and I started back in 2001. Before 3D printing was cool. It was just rapid prototyping, and no one knew what that was. You'd say, "Oh, I do rapid prototyping." Their eyes would glaze over, and they'd say, "Oh, that's nice. Good for you." The industry certainly changed. When I started back then, I was just scrubbing parts in the back, and I slowly crawled my way up the corporate ladder of this small elite team. But it's been really fun. We've constantly had to reinvent ourselves from a traditional, SLA model making bureau to one that's like a true additive manufacturing, and Origin's been a big part of that.
That's awesome. And Tim, our application engineering manager for Origin One here at Stratasys, has been a part of the Origin team since 2018. So way before Origin was a part of Stratasys. He's kind of grown up with us. And he has an incredible understanding of the Origin system, as well as an extensive background in 3D printing. So welcome, Tim.
Thank you, Becca.
Yes, if you'd like to tell us a bit more about your background as well.
All right. Can you hear me?
Yes.
Okay, cool. Yeah, like Becca said, I've been with Origin pushing 4 years now, about 3.5, and Stratasys since the beginning of last year, of course. So I'm excited today to talk about printing on the Origin, specifically adapters and connectors, and let's get rolling.
All right, let's do it. All right, so now that you're familiar with our two excellent speakers, I just wanted to give a brief rundown of what we're going to be covering over the next 40 minutes or so. We're going to stay fairly technical today. We'll be jumping right into how to augment existing designs of adapters and connectors so that they can be 3D printed. Tim and Dan will show examples of how parts can be changed to ensure that they print perfectly, and share a few DFAM or design for additive manufacturing principles that you should keep in mind for small and fine featured parts, just to ensure that they print exactly as desired. We'll then move on to discuss how materials should be selected, with Dan giving us some insight into how that works from a Service Bureau perspective and working with clients, as well as Tim's perspective of doing it more in-house. We're then going to move on to take a look at how to evaluate if the Origin One specifically is the right printer for your needs, and also when our technology, programmable photopolymerization, or P3, which is the technology that makes Origin unique, when is that the right technology choice? Finally, we're going to move on to how to evaluate if there's a positive ROI for switching a part to 3D printing and away from other means of manufacturing. And then Tim and Dan will show and explain several real-world examples of these types of parts being made. We're going to wrap up, as I mentioned a little earlier, with a brief look at the Origin Lab at Interpro with Dan, and then have an open 15 minutes Q&A at the end. So please feel free to submit any questions throughout the presentation. All right, Tim, let's get into it.
All right. Thanks, Becca. So whenever a customer, an organization is making the switch to additive or adding additive capabilities, one of the first things that's often done is, choosing an existing part to print. And the first question that's often asked is, can I print this? The answer is usually yes, assuming it can build volume, it's supportable, there's no super tiny features. But I think a more important question is, should I print this? It's important to ask why you want to print any specific part. Is there gains to be had? Are there gains to be had in time? Are there gains to be had in cost? Do you plan on modifying your design to consolidate parts, lightweight, topology optimization? So it's important to ask, does the cost structure of this part make sense? Is there value being added to the organization? Oftentimes with the design constraints with traditional manufacturing that are relieved when you switch to additive, you can get an advantage or value in producing that part for parts. So question for Dan, in your business, how often do you get to work with customers on modifying designs or creating designs that are specifically designed for 3D printing?
The quick answer would be more and more every day. I think, 3D printing is about solving problems, and with, the current situation in the market, supply shortages, there's more problems than ever, particularly even with remote workers. So how things were traditionally incepted have changed quite a bit, and 3D printing can sometimes, reduce risk for a new product launch. Maybe you don't have to go to hard tooling, you can seed the market. Or if a tool is not available, we saw that particularly in the early days of COVID, our clients couldn't engage with their tool makers in Taiwan or overseas, and quick solutions like 3D printing, particularly the Origin and some of its more advanced materials, really helped catch up. So we saw initially a period where people were, normal, I want to say shoehorning like current designs into the Origin platform to kind of fill that gap. But after they got comfortable, maybe 2 to 3 orders, then they had a good confidence from even like a marketing standpoint or engineering standpoint and quality to start designing for the process, and really that enabled them to grow their market share or, deliver better products. So it's happening, I'd say, weekly at this point. And some of the questions you have here, Tim, are really good. The one thing I do encourage people is not to look at ROI from the part cost off a printer, like build time and material, that you really do want to look at what problems this solution may be solving for your organization. If there's multiple parts that could be built as a monolithic unit, what does that do for the quality burden? There's a lot of, the more questions you ask, usually the more you can answer with this platform.
Yep, exactly. Well said. So I think before you start printing something, ask yourself why I want to print this, what value is it going to add? And if so, get started printing it. Moving on. Oops, I think I skipped one. All right, here we go. So every manufacturing process has constraints. Traditional manufacturing with CNCing, injection molding, casting, you need to design, or folks always should be designing for manufacturing to gain savings on labor, material consumption, cost, things like that. So although additive manufacturing in general, and specifically on the Origin One, does have some constraints, they're typically less than, but different than those of traditional manufacturing. So the main types of features to be looking out for with any part, including adapters, connectors, and the like, are islands, overhangs, and orientation considerations. So the goal of considering these things early in the design phase is really to optimize quality, maximize throughput, use material efficiently and minimize your use of material and consequently cost. Minimize labor for post-processing, again, to minimize cost. Thinking about orientation during design can definitely help with throughput. One of the benefits of Origin One and similar technologies is that the print time is dependent only on the material and the Z height of the part. So printing parts in an optimal orientation will often give you the best throughput. So the impact of designing for additive in general doesn't matter as much if you're doing rapid prototyping, because you can stand the parts, put in the effort, and it's often worth it. But as you get towards production and mass production, the impact of those design changes become larger and larger and make a bigger difference on the bottom line. So Dan, you've had a printer for a while now, and these days you're definitely pro level. But can you talk about the process from originally getting your printer until being comfortable to design parts for it or inform design for it? So
Sure.
How was that process for you?
Yeah, it was interesting. It was easier and harder than we thought. Partly, we'd been an SL company for years and very used to, those kind of support structures and that kind of build orientation. And, we kind of brushed it off like, oh, the parts are upside down, no big deal. But that, the fluid dynamics, little changes like that really we had to unlearn some things. So I think if we didn't know anything, we probably would have had a very different experience, but we had to kind of deprogram ourselves from traditional like SL setup. And then from there, it was really just, learning the materials. The machine install was like an afternoon, which we were used to like week-long, sometimes month-long installs on other capital equipment. So really, it was just starting to figure out some of the nuances of the machine, but really the setup process probably was the most like learning we had to do. And then after that, it was kind of off to the races and really learning the materials. And, we started 3 years ago, so there wasn't a lot of, besides sample parts from Origins, there wasn't like a lot of parts out to see like, hey, is this good quality? So we started basically just competing with ourselves and trying to outdo ourselves. And we got ourselves into trouble, sure. Leading edge, bleeding edge. But it was also a lot of fun. The team really got excited about kind of tackling these new challenges.
Cool. So when you're working with your customers, do they quickly understand the value of being able to change their design? And how often does that actually happen?
It's one of the things we got better at running the machine, so we didn't need as many designs changed, so we were able to figure out certain things. That said, eventually once programs really, like you kind of mentioned before, really started gearing up beyond the 10 or the 20, we really wanted to change things once we also knew, particularly on the post-processing side, that's where we took a lot of things for granted and eventually had to build new processes, because eventually when we had one printer was different than when we had 4, and now we have 5 technically. And it was that uptick of part production really kind of swamped the boat. So we had to figure out how to clean the parts quicker. And that's when we started working backwards. Well, then the guy's like, if this, I'm getting resin trapped here, if this was, different, or even from a scrap rate kind of standpoint, and we were going after some pretty tight tolerances, even back in the beginning. So there was a lot of, small changes, little offsets of features. But for the most part, our clients, I think, were so excited by the material advantages to using these like new chemistries that our clients were very generous with giving us some leeway to kind of learn and basically do paid R&D.
Yeah, so that paid R&D seems like a nice way for you to learn how to tune the system to achieve those things like accuracy and part quality. All right, I'll let somebody else go to the next slide because apparently I'm terrible at it. So on this slide, I'm going to give a couple examples of the kind of things that we typically need to change when you get a first design, and then what that design looks like after you optimize. So I mentioned earlier, one of the things to look out for are overhangs. Unsupported overhangs, when they're horizontal and bigger than 2 or 3 millimeters, often need support, which isn't that big of a deal. It takes a couple of clicks to build the supports, a couple minutes to remove them. But oftentimes they're either not removable, or they're removable and you need a Class A surface, and you might not be able to sand that surface. So in that case, you can do things like angling the overhangs such that they're self-supporting. And you can see in the bottom left there, that's what happened to that tab. And in the bottom right, those arms got that taper there. So both of those parts became fully self-supporting. And another step in the process is removing the parts from the build platform. And in general, this takes, a couple seconds, half a minute, up to several minutes, depending on the geometry you're printing. So there are tricks you can do, like add a fillet or a chamfer to the surface that's touching the platform, to help you get that scraper under there and remove parts quicker. And for both of those, the goal is to minimize labor. And lastly, making design changes for aesthetics, things like adding a logo, can be done same day. So it really speaks to the adaptability of it. Oh. All right, thank you. So similar story here. Removing or modifying horizontal overhangs to be non-horizontal, or even eliminating them if the design allows, are great ways to minimize labor for supports. Another consideration is design for cleanability. This is a resin process. When the print is done, the parts are going to be covered in resin that needs to be washed off in a solvent bath. So in general, blind holes, narrow channels, very small holes, and negative features can be challenging to clean. So in this case, the design allowed for making like a venting hole where a blind hole was. So the holes are able to clean easier. You minimize your part's exposure to solvent, which does maximize your mechanical properties. Other things, like if you have a negative feature with a sharp corner, those sharp corners can be tricky to clean. And again, by adding small fillets there, you're able to make the part clean easier, which is not only time savings, but again, minimizes your exposure to solvents. Who's pressing next?
All right, cool. One of my favorite things is to talk about materials. So one of the reasons why I got into the Origin platform originally was that we had kind of identified, Interpro does a lot of, we do SL, we do powder bed, we do cast urethanes, and they all solve a lot of different problems, but we really wanted a solution that had really great material properties and really great finishes, particularly with connectors and small, components like this. There's quite a burden on quality, right? So since it's such a small part, usually it's got very fine features. By the nature of it, it's often operating in cramped areas and whatnot, that the materials have to perform to a certain level, just based on the geometry, and the features have to be there, as well as the surface finish, right? Because there's often things are sliding together and connecting, right? They're holding things together. So there's quite a lot that has to be kind of baked into this small piece. And, for us, connectors often, they can't cost $1,000. And so we needed economy of scale as well. Now, the thing that made me most excited about the platform, though, was really this ecosystem of materials. And, as a service bureau, we don't build things for ourselves. We're building things for other people and solving other people's problems. And so how I interpreted that ecosystem of materials from Loctite, BASF, and now Covestro, was that there was a plethora of materials that we had access to, which meant we could solve so many more problems than we ever had before. A lot of other traditional materials, hit like a threshold of elongation, right? And so when I was quoting jobs, it'd say, hey, you can go with this material, but here's the cutoff, and the clients would kind of live with it. Whereas now we can print and Loctite's 3995, and it's an FST part, and it's got smoke and toxicity. It's stiff, low shrink, but even some of the more what we would call more functional resins for like production is like the QuickGen or the IND 4 or 5 by Loctite. This is when you get elongations of like 40%. The Clear 3172 has an elongation of 140%. I mean, that's just kind of crazy, right? For thermosets, right? In traditional, these were conversations we were never involved in. I've never talked about elongation more in my entire career at Interpro than I have last year. And that's super cool, to be honest, because these are problems that, would have stopped at 3D printing's door previously, right? You kind of hang out and do the one-off prototypes, and then they'd go to rapid tooling or, figure out something else. And particularly with connectors, as anyone does cast urethane here, those are tough parts to cast, right? Or, maybe you could do it and no one's going to want to pay that butcher's bill. But then we get like other, quote unquote GP or general purpose materials like the 3843 or the ST45 that, the 3843 has like a mattening agent in it, which produces really good looking parts. But again, it's a very functional material that way. So it was exciting for us. And when Tim was talking about like DFAM, you can, modify the part for the process, but you can also modify the part for the material, right? So we've had projects that, lived in 3843 for a while, and then they're like, well, we want a little bit more, elongation. So let's bump it to, IND 4 or 6 or something like that. And before, if someone said, hey, let's say 10 years ago, the conversation's like, hey, the part's broke. And you go, can I quote you another one? It's now we have the ability to say, yeah, we can quote you another one. Let's try this material. So it's very, I think, and personally empowering for Interpro, but also our clients seem to be really understanding and appreciating that flexibility, that if things don't work out the first time, or, the ability to get closer to truth, right? The actual, what that part is and what it can perform is, we can go further into that conversation. So it's if you geek out on materials, it's a pretty fun place to play
in. Well said, Dan. So two aspects of materials that are special or relevant to the Origin platform. Number one is the open ecosystem that Dan talked about with our 3 big material partners these days, Henkel, BASF, Covestro, DSM. There's a very broad portfolio of offerings. And for any application, there are many characteristics of the material that need to be considered. For connectors, things like temperature, FST ratings, chemical compatibility are all very important. You also need to consider economics for anything or many things. And then depending on the functional loads or conditions the part's experiencing, you need to consider the flexibility, strength, impact strength, and then Dan's favorite, elongation, of course. So the other aspect is how easy it is to change materials. This is important not only for service bureaus, but for many customers. If you have 2 trays, you can swap them out in sub 30 seconds. With 1 tray, you have to clean it. It's a 5-minute process or a 10-minute process. So really the diversity of materials that you can choose, how easy it is to swap from one material to another, really leaves the only question is, what material should I print with? And the materials Dan described are some very good ones, but far from the entire list. So one question that's often asked is like, why do I choose the Origin One? Very good question. And my typical answer is, it's a great printer when you need surface quality, accuracy, and functional, robust mechanical properties. Time to part is also super important. Getting parts the same day is very often possible. And next day in just about 100% of the cases at worst. So material efficiency, material efficiency and print success are also important factors. So Dan, obviously you guys have a lot of experience in additive, going back to when it was called rapid prototyping and before. What really sold you on the Origin one?
Probably the first time I saw that image of that textured sample, because we've been using other processes, which we still do, of course. No one printer solves all problems, but there really was like a line between like functionality and like surface quality, where we had applications that just had to exist in water or grease or something where it couldn't have porosity. And particularly at that time, that's what we were kind of looking at. And our cast urethane business has always done very well and was growing where clients wanted color and elongation. So what kind of sold us in that process is that literally that picture. And I saw that, and I kind of had a bunch of clients in mind that I'm like, well, this is a bunch of work that we haven't been able to address, either from a capability or a capacity standpoint. And so I'm happy to say, like 3 years later, a lot of those accounts and opportunities have been realized, and we're actively producing parts for them. But I think a lot of, particularly the service business, you just kind of have a gut sense of how you service clients. If it's kind of like the restaurant business, they're hungry. You just got to figure out if they want burgers or if they want steak. And the Origin had a lot of sizzle to it, as they say in sales, and I could just see that servicing a lot of opportunities, and particularly the material diversity, the fact that, like you said, other machines are they sit in place and then you have one material dedicated to them, whereas this is like you could just pop out a tray. You could do clear parts in the morning, rubber parts in the afternoon, and a long overnight build. So that was very exciting to me.
So in general, with every manufacturing process, no tool is right for every job. And that's absolutely the case with additive as well. So many times, a powder system, a stereolithography system may be the best option. Conversely, many times the Origin P3 system is the best option. One of the biggest cons with the Origin and other DLP systems is build volume. So many parts just don't fit unless you chop them up. And if that's the case, powder or SL or FDM may be a better option. But like I said before, if you need surface finish, part quality, and functional materials, that is when you want to start thinking about the Origin. So it's also a very deployable system. Like Dan said, it takes hours to set up, not days. So you can have your first part the day it's installed. But it's also adaptable in that you can, if you're a large company, you can have printers in various locations. So you can print, parts in the development location, lock them, and then same day print those parts in your production facility. So rather than talking about the printer cost, we like to talk about cost per part, which again becomes increasingly important as you move towards the production end of the additive system. All right. So I mentioned a couple times, one of the important things to consider is the economics of producing a part. When you're manufacturing things at scale, it is absolutely a very important consideration. So with additive compared to traditional, many times the part cost is higher with additive. Other times it's lower with additive. Other times you're doing things like part consolidation to look at the overall cost of an assembly. But one very important thing that probably is not news to anybody is tooling error is a huge factor. So even though the part cost of making a pen cap is a cent compared to printing it, which might be tens of cents, if that tooling cost is $100,000 and takes 4-8 weeks, additive is definitely a better option for those small volumes, medium volume, but also fairly high volumes. Again, it's very dependent on the part, but for adapters and connectors that tend to be on the smaller side, it's very much possible that you end up saving money when you're printing the same part, as well as getting the parts faster. So, question for Dan. Have you found that your customers are saying my supply chain or my ordering process is easier or more efficient or more difficult with additive production?
Generally, particularly in the last year, it's easier with additive. And one of the reasons why is there's not as much setup involved, right? So they don't have to order as much. A lot of the, particularly where we're based, we work with a lot of OEMs and medical equipment suppliers. And one of the big things that they look at is just how much, unfinished inventory they have on hand, right? I went to one client site and they had hundreds of millions of dollars of unfinished inventory at any one time, right? And so if they don't have to hit a huge, number, if they don't have to buy 1,000 parts just to get the per part price down, and then those, that's cash out of pocket that's sitting there on a shelf for quarters or a year. One of them quoted me saying like, yeah, I can just order 10 parts from you. That's great. I don't have to order the 50 from the traditional CNC shop and pay that, so cash flow, I think, particularly with COVID and, uncertainty related to customer orders, really became like a benefit that they could just take these, these smaller steps. Was just a lot less risk that way.
How have you found your production efficiency changing as you scaled from your first printer to 4, 5 printers?
Yeah, it's actually really funny. We didn't quite realize it. So one printer, we were in some ways like terribly inefficient. Again, we're a fast-paced environment. There's a bunch of machines. We keep kind of a lean and mean team, but the printer was incredibly fast. Like some of our SL printers, we'd kick it off and walk away, and you'd show up the next day, right? Well, when we kicked off our first few jobs, they're like, oh, a half hour. That's awesome. And then we'd walk away, you get coffee, you bump into someone, you check your email. By the time you get back, you're like 2 hours have gone by and you're like, I had more bills to start. But once we had more machines, it's amazing. Like it was just like a curve. It wasn't a linear growth. It was like a bell curve. We just kind of rocketed up in terms of, because now basically it's kind of like working a commercial oven. Like something was always coming out. Something was always, a new build was getting started. So it was much easier, and people actually found the experience much more rewarding because there wasn't a sense of guilt. Like, oh, I should have started that a half hour ago. You're just streamlined to do your workflow and, pop on the tunes and have at it.
Yep. That makes sense. I found that when I'm able, or somebody in my team is able to devote a block of hours in the lab when you have multiple machines available, there's always something to do, for the first job that's done, next job that's done, next job you're preparing. Where it definitely feels a little more efficient if you're bouncing back, a little more inefficient if you're bouncing back and forth between the lab and the desk to do desk tasks. Tell us about Distech then.
Cool. Yeah, this is always very exciting for me. We're on year 3 of this program. And so Distech is a company. It's one of our clients, and they do bioreactors. And they needed to basically have it's called a motor mount adapter. So they have a motor that basically stirs the slurry for their product. And in some cases, the clients had their own motor. And they said, oh, we don't want to buy yours. It was a small line item, as I understand it. And they just wanted to be able to address the market need, right? People didn't want to, and they didn't want to forestall a larger sale for this kind of small one line item. And so actually we designed, this part was designed. And as you can kind of see, it's, maybe in my heart, I feel like it's like the quintessential 3D printed part, because you wouldn't do this any other way. You wouldn't injection mold it. You wouldn't CNC it. But it's very functional, right? It's holding 2 holes in space, right? It's kind of perfect that way. And what we saw is grew out, because this is actually a customer-facing component. It's not buried anywhere, and they have their logo on there. It's actually pretty front and center, but and this was a case where we tried a few different materials first and landed on Loctite's 3843 with a matte version, and it looks beautiful. And they found that they, had a lot of success, and now they could, very quickly facilitate the sales process by introducing a new SKU number. Right. If a client says like, no, I got this motor, they'd be like, that's fine. We just, design another SKU, another part, and, submit an order for 5. I mean, that adaptability is, I think, the real main conversation that 3D printing should be centered around more and more. It's that ability to address, almost not quite real time, but pretty quickly, market concerns, market being your end client. So you can, iterate faster, and you can get to production faster to facilitate sales and growth, rather than, again, slowing things down. So I think nowadays we've had almost a dozen SKU numbers of these. We're running our biggest order ever this year with them. So it's really exciting, because this was one of those parts that I saw that in the very beginning. I'm like, that's an Origin part. And it wasn't just a pipe dream that, we did see clients really benefit, particularly in this case, by going this route.
I remember when I first saw this part, I got excited instantly, because it's a perfect part for the process. It prints totally unsupported, customer facing, so it needs to be beautiful. And I'm very glad it's stuck, and they're still ordering from me.
Mm-hmm. Cool. Here's another application for a client. This is, again, a client that does a lot of switches. In this case, it's an automotive connector, but for them, we would often do a couple SLAs, and then they'd go to rapid tooling, just to be able to basically get that the required geometry and material properties for their advanced testing, even before they went to production. And again, like I mentioned earlier, the sheer form factor of a connector or a switch of this size makes it, I don't want to say prohibitively expensive, but makes it for expensive tooling. A lot of features either have to be EDM'd, do some syncer, or they have to be, much more elaborate tooling, or some concessions there. But with this case, I'm excited that this kind of was well received, because these were one of the original clients I thought about getting the Origin for. Is that, we'd be able to produce these parts very quickly. It's 5 parts an hour. And then in a material that was much more similar to ABS than any other process currently can offer. These were also printed in 3843, and that has an elongation of around 40%. So that's pretty good. It goes together with like a silicone component that we molded in-house, and then there's a nice snap feature. But the part's also fairly rigid. I think, traditionally, even in the casting side world, there was always material concessions. Like if you wanted elongation, you'd give up on durometer or flexibility, right? The 3843 is, I think it's around 1800 MPa on the FlexMod side, and with the 40% elongation, right? So that's, I think, kind of the exciting things is it's not that seesaw of rigidity or flexibility and elongation, that they can both move in similar directions. So in this case, now the client still is going to go to injection molding for more advanced testing, but they're able to get more out of the prototype program longer, basically. So, we made a bunch of these parts. They went overseas. They're living in cars. And so that's really cool, is because it's not just a snap fit, A-OK, sitting on someone's desk. They're actually out in the field getting actionable data off those advanced prototypes.
Yeah. It's always great to see parts that you print end up in a functional application, like in a car. And printing snap fits is always really satisfying to feel that snap.
Mm-hmm. Well, yeah, feel the snap and not cringe, right? When something snaps off and goes flying.
Yeah, to confidently feel that snap.
Yep.
So electrical connectors are a great application for 3D printing on the Origin One. all the connectors that we've printed, both on this picture and others for customers and not for customers, 3955 is one of the first places to start. With electrical components, FST rating, so flame resistance, self-extinguishing is super, super important for obvious reasons, right? You're running wires and electricity through this plastic part. 3955 is the first and to date only photopolymer that is FST V0 rated. It's also very chemically resistant against a whole bunch of chemicals like gasoline, other hydrocarbons, solvents, water, etc. So not only is it heat resistant, it's good for fire and FST applications. There are thousands of these out there. If you go on McMaster or some other website like that, like 1,000 is definitely an underestimate. And sure, there are thousands on McMaster, but when you're designing something new, maybe any one of those many thousands don't fit your application. So 3D printing the connector directly not only gets you faster to part time to assembly, but a fully functional device as well. Do you want to start here, Dan, or shall I?
Oh, yeah, you go ahead.
Sure. So one of my fun projects these days is this Y connector, or Y splitter. So I recently got my own 3D printer at my house. I like printing things for fun as well as for work. And I wanted to run an exhaust out of the garage. So rather than cutting holes in my garage, I decided to tie it into the exhaust for the hot water heater with this printed Y connector here. So some of the considerations were there would be high temperature air flowing out, so I needed something thermally resistant with a good HDT. There were going to be chemicals coming out from the printer, so I wanted something that would be very chemically resistant, and also something strong and stiff, so I can bolt that fan in and bolt it to the wall and have it stay securely. So that's one fun example I designed and printed. But again, there's tons out there, like tubes, pipes, connectors with air, liquids flowing through them, all over the place, hundreds of different sub applications. So it is an interesting one, a common one, and one that the part functionality and cost often makes sense. Have you found that pipes, tubes, splitters, things like that, Dan, are common in your business?
Yeah, I think they tend to be, again, where we're located in New England, we're heavily medical and heavily aerospace. So the pipes applications that we get introduced to are usually on the aerospace side, where there's a different burden of quality or material that they're solving like different problems, with their traditional processes, or a lot of times it's trying to glom multiple parts together that would be, a mixture of machined, end caps and, overmolded flex hose, things like that. And it's still very much in the experimental stage, I would say. But the FST was kind of a game changer, because then, more and more parts on planes are being turned into plastic, but there's a different burden for that, a flame, smoke, and toxicity rating.
All right, great. And I think that brings us to Dan, if you'd like to give us a little lab tour of your setup. I know you have a really great setup with a few Origin printers.
Sure. It's going to be, I don't know if anyone has those commercials, the old Bob's Furniture, but it's going to be one of those come on down moments. So, all right. So this is our additive lab. We're actually getting a new Stratasys Neo installed at the moment as well. So it's fun. It's fun having a lot of different toys. And the one thing I would add to like Tim's comment too about making your own pipe connectors and things, that once you have like a tool in house, it's kind of amazing what you can do with it. Like it really does change what you think is capable. So there's our 4 primary machines. We have a 5th up at our Rocky Hill facility, and that's kind of dedicated to a different other applications. But really, the amazing thing about the process is that even like from a flatness standpoint, I don't know if anyone's like a tool maker, but if you are, you kind of get obsessed with flatness, and like that's always kind of a sacrifice that certain other processes just can't do. But you can do that with the Origin, and here we actually have some of the different Destech parts. This one's in the Cyan 3175. And then, again, in terms of flatness, here's like a kind of a test injection mold we were doing. But, we wanted to do injection molding out of SL for years, and we just could not achieve the flatness. We'd have to secondary machine everything, which, again, kind of defeated the purpose of 3D printing in a way. And but with an Origin, this DOP process where it's building against glass, we can actually achieve some pretty tight stuff there. I saw there's some questions about small features. To answer one of those now, it really depends on the material, and that's not a bad thing. I mean, we've gotten really small features, really tight tolerances. This is the RG35 material. I don't know if anyone can see just that threading on there. I mean, my camera can even kind of pick up, how small that threads are, but it's really cool stuff. And, in terms of tolerances, we've gotten ±1 before, but that's, a good qualified part that's dialed in a little bit. But I would say this was the part that launched 1,000 parts after it. That's what really got me going on this process, is to be able to have that texture. That was pretty amazing.
That's awesome. All right, I think we can move on to our Q&A. Unless, Dan, there's anything else that you would like to show us?
Yeah, I don't want to. I could talk forever, but I'd rather answer people's questions. So I'll shush up now.
All right. We actually got a ton of questions during the talk, so thank you everyone for that. I will go in order. So John is asking, if possible, can you show printed parts with supports and talk a little bit about the support removal process? And specifically, will the water jet that they have for the Objet 30 be obsolete, or can they continue using that?
Yeah, I can answer that one, Tim. I don't have any parts with supports on them. I don't know if you do. The water jet, I wouldn't advise. I mean, you could, but there's other ways. We're working with post-process and Henkel Loctite to basically just use ultrasonics and other different cleaning agents to process the parts. So really, to be honest, if you can figure out how to not touch the part, that's the best option there, particularly if you're looking at volume. I mean, we do tens of thousands of parts, so if we have to manually hold a part at each stage, that's not adding a lot of value to our clients. So I can say there's some good solutions to automate part cleaning now.
Okay, great.
Yeah, my one thing to add, the process is print the part, remove the part from the platform, remove supports if needed, clean, then post-cure. Removing supports, removing the part from supports really varies depending on how the supports are designed. When you design the supports perfectly, it's super satisfying. Like peeling off a strip of Velcro, it takes a couple seconds. Other times, if you're over designing the supports because you're going to be sanding them and you want to maximize quality, reliability, it can take a couple minutes. You can trim them with snips, but I don't have any examples of parts with supports at my desk or on my shelf. Because when I design a part, I really try to make it self-supporting, which not always the case, but nice when it can be.
Awesome. And Dan, just to follow up with that sample that you just showed us, how do you deal with close tolerances, and what's the tightest tolerance you can achieve?
Yeah, so generally we found the more rigid the material is, the better the tolerances we can achieve. So like Loctite's Pro 410 Black, RG35 by BASF. Those are pretty rigid materials, and we've gotten ±1. Now, when you talk about there's accuracy versus precision, right? We did a run for a client where they needed ±1 and a much more flexible material. We did, and they needed, let's say, 600 of them. We were able to supply 600, but we had to print 1,000 in that case to achieve it, right? So we had like a scrap rate that was kind of built in, and they accepted because they didn't have any other options at the time. But consistency is part of it. But again, they selected a functional, more flexible material, which we weren't as consistent holding that tolerance. So again, I think that speaks to the flexibility of the system and the materials. Because to be honest, even if we scrapped 400 parts, that was 4 hours of printing, right? Because we were printing, these were small connectors. We were printing, I think 50 an hour or so, maybe 100. I can't remember. We did a couple different runs, but and the nice thing was we were able to augment that on the fly. Print 50, measure them. Nope. Print another 50 with offsetting the CAD. Because you can compensate in the machines a little bit, but really sometimes it's a little bit more controllable. At least we found it in a fast-paced environment to compensate in the CAD and note that.
Perfect.
Yeah.
I think
Yeah.
a good follow-up, or sorry, go ahead, Tim.
We might be talking about the same thing. I just want to clarify for the rest of us metric thinking folks out there. When Dan says ±1, that's 1,000th of an inch, 25 microns, not 1 millimeter, which is
yeah, big difference.
Yeah. I think that actually works well with the next question, which is how did the Origin impact your quality control process? And if you could compare it to like an SLA system, what differences do you see there?
Yeah, so simply the sheer volume, right, of parts was like, do you need to inspect 1,000 parts? Was an SLA, the onesie twosies that we were doing are really big parts, Origin kind of changed what we consider a lot batch, right? So there's a lot of standards, particularly that are being put onto 3D printing, which are more adapt to, injection molding. All right, if I have multiple machines and producing the same part, do I have to put them under the same burden? So we kind of basically developed our own quality system for measuring lot sizes and inspection in multiple stages. But again, a lot of that's client driven. But it did just the sheer volume of parts we were doing and as fast as we were doing them in, kind of changed the way we think about it.
Perfect. And also, and Tim, I will serve you a question just after this, but this is just perfect for Dan's current view. Do you have a post-processing station that you could show?
Probably not, to be honest. I've only scrubbed this half of the lab from client data. But we have multiple post-process units we found. Again, Interpro really leaned into the forefront of this, and we took on a lot of different materials, and each one we got really into it and found different workflows that work best from a timing. Loctite, I know, is really developed quite a really good workflows for you to follow through. But we have a couple different processes, but generally like an ultrasonic with a certain type of bath, or like the post-process. I think they make one specifically for DLP, or they will. There's definitely a lot more tools out now than when we got started.
Awesome. And Tim, I think you're the perfect person to answer this. Can you talk a little bit about Origin's material catalog? We have especially interest in the strategy of partnering with chemical companies, and also where the support for materials comes from, whether that's Stratasys or the vendors directly, with reference to Carbon3D's kind of restricted material selection.
Yep. I think there were 6 questions in there, so I'll try to remember them.
No, sorry.
So, number one, yes, I can definitely talk about the material portfolio. I probably looked at the TDSs for each material, I don't know, dozens of times. But Dan described some of them on one of the previous slides, but kind of the extremes are the elastomers. One of our go-to elastomers is about ABA with super tear strength. great resiliency as well. On the other end of the spectrum are the high modulus, high strength things, up to 80 something megapascal tensile strength, modulus up to 3,500. And then I think in the bread and butter wheelhouse area are the general purpose materials that are tough, fairly rigid, quite strong, just good for a lot of applications. I mentioned 3955, the FST material. We have some other high heat materials, and many more to come. And the many more to come kind of speaks to our strategy about working with these material partners in this open ecosystem. So I think it's important and a smart idea to let a printer manufacturer focus on manufacturing printers, and to let these enormous chemical companies that make a gazillion chemicals focused on creating material, because that's their business and that's what they're good at. It's really hard to scale to somebody the size of a BASF or a Henkel or a Covestro. And it's hard to match their resources as well. That's really why we have that strategy. Becca, can you help me out with some of the other questions at the tail end of the question?
Absolutely. And then, so you just talked about support coming from the vendor, and then we currently use Carbon 3D where the material selection is restricted. Our portfolio has about 10 materials right now, but then we also just added an OML.
Yep. So today, materials that customers can use are divided into two categories. One is certified materials that we have extensively validated, we know very well, and we support internally. Material partners support as well. And the second is when you have the open material license, the OML, you can print any compatible photopolymer, of which there are, I don't know, hundreds of thousands in the world. And of those, we've printed 20 or 50 that are not certified, but well known and well understood. So we can give a different degree of guidance on those. I think that's super valuable for customers. I think that's what made Stratasys be interested in Origin in the first place, or one of the things. And I think that's also influencing the broader 3D printing ecosystem across companies. People are opening up more because they really see that value in the open ecosystem.
Absolutely. All right, Dan, I have another one for you. This is specifically for you. Once you'd corrected in CAD for the plus minus 1 thou, what percentage of faulty parts did you get? And what reason would you explain any newly non-conforming parts? And do you know how those could be avoided? Or is there anything that you'd like to talk to about that?
That's a great question. One thing I will say, like each material kind of has a different workflow, and the SL world, like tolerances are kind of baked in. It's been around for 20 years. The process is fairly consistent. Loctite provides workflows that have recommended dwell times, for example. So, for example, 3 years ago when we got really going, we're going to slam out this thousands of parts. Meanwhile, it took 2 days for us to clean them by hand, and they had actually gotten out of spec, right? Because they had started to absorb materials or get flexible when you're like, oh, you can't leave them out for days, like, that particular material. So there was some learnings there that you kind of have to have a certain operational rigor. Again, depending if you're trying to, some materials, it's harder to keep that up. And there's things that, if you leave them in certain, we tried a lot of different cleaning agents, and some of them like absorbed that cleaning agent. And then we threw them into the ovens to cook, not knowing that it hadn't finished baking off all the solvents. So there's a lot of little things. It's not really hard math, to be honest. It's just that we had never had to think about that previously, because it was never, these like fine tuning of like mechanical properties was never an option to even consider. So a lot of it for us was just like, oh, we have to think about that now, right? I think we had to grow up a little bit for that production environment. So as an organization, we just had to kind of step up and have more awareness of where things were in the process and how these little decisions we've made during the day affect the end deliverable. And we actually, in the end, had to slow down a little bit and realized that, slamming out 1,000 parts in a day was cool, but ultimately potentially not helpful and more risky, right? So that was kind of where we like started the run, tripped, and then you're like, all right, well, we're going to do this again. But that said, the materials, again, Interpro took on a ton. I think we're actively running close to 15 different materials. Some of them are not on the Stratasys list of validated. So, we kind of figured out that certain materials basically could hold a tighter tolerance easier, whereas other ones we kind of had to work for it or had a bigger scrap rate.
All right, perfect. And we are actually 1 minute over our time, and we still have questions coming in. So I just wanted to let everyone know that any questions that weren't answered, we will send in follow-up emails. And I think we can just send everyone the answers to those questions. I'm sure everyone is very interested, but I wanted to thank everyone so much for their time. Thank you so much, Dan, for joining us today. And thank you so much, Tim, for giving your expertise. This has been awesome. So everyone knows, you'll see a copy of the slides and a recording of the webinar come through as a follow-up, and we will also be answering any follow-up Q&As. So thank you again, and everyone have a great rest of your day.
My pleasure. Thank you.
Thanks so much.
Thank you, guys.
Take care. Be safe.
Good job, Dan.